Welcome everyone to our webinar, Orchestrating DERs Across the Grid Edge with GE Vernova and EnergyHub. Thank you all for joining us today. My name is Heather Tatt, and I'm the Product Marketing Manager for GridOS DERMS here at GE Vernova, and I'm excited to be your host for today's session as we explore our innovative partnership with EnergyHub and how it's set to redefine the management and optimization of distributed energy resources. Today, we are privileged to have with us Kristen Kuzel, our Senior Manager of GridOS DERMS at GE Vernova, and Matt Johnson, VP of Business Development at EnergyHub. Both Kristen and Matt bring a wealth of experience and deep industry insights to our discussion. Throughout the session, we'll explore how the convergence of GE Vernova's GridOS DERMS and EnergyHub's Edge DERMS enables utilities to better manage the complexities of the modern grid. And towards the end, we'll also share a live integrated demo that showcases how the combined power of GridOS DERMS and EnergyHub's Edge DERMS can unlock value for the utility. Before we dive into the content, a couple of housekeeping items. Firstly, during the webinar, we encourage you to ask questions in the chat as they come to mind during the presentation. And we'll have a dedicated Q&A session after the presentation to address as many of your questions as possible. If we run out of time, don't worry, we'll be able to follow up with you post-webinar via email. You'll also notice various interactive widgets throughout the webinar platform, such as booking a meeting, participating in a survey, or asking questions. So please feel free to engage with these as we go along. And I think that's everything. So without further ado, Matt and Kristen, I'll go ahead and turn it over to you to introduce yourself and start our discussion.
Thanks, Heather. Thanks, everybody, for having me. As Heather mentioned, my name is Matt Johnson. I'm the Vice President of Business Development at EnergyHub. I'm responsible for external partnerships at the company. For those of you who are not familiar with EnergyHub, we're a leading provider of Edge DERMS software for control of behind-the-meter DERs. Looking forward to the discussion today. And now I'll turn it over to Kristen.
Thanks, Matt. Hi, I'm Kristen Kuzel. I'm a Senior Product Manager on GE Vernova's DERMS product team. And my primary focus is on the gateway module within the GE DERMS, which handles the bulk of our external integrations, including those with edge providers like EnergyHub. And today we'll be talking, as Heather introduced, a little bit about why an integrated solution across both systems brings a lot of value to our utility customers. So to get us started, we'd like to talk a little bit about why we think it's important to provide an integrated solution across a grid-level DERMS and an edge-level DERMS. Answering the obvious question, why do I need two separate systems? So in a traditional configuration where you have the two systems operating independently from one another, you'd likely see a setup like this one with one team at a utility managing DERs through one system and another team managing DERs through a different system, often in a different room, and they lack communication with one another and visibility into each other's actions. So in this slide, we see a common example where neither team has visibility into the other's actions, and as a result, DERs are used inefficiently and users may take action where not really needed. Here we see that one user, the program administrator or a demand-side management team, may elect to dispatch DERs through the Edge DERMS system. But on the other side, we have a control room operator that has no visibility into this action. They can't factor it into their own grid management strategy. And furthermore, those EVs may not even be controllable through that control room in this scenario. And so oftentimes those DERs are going underutilized, or the grid operator is not in a position to leverage them for their own grid management strategy. Looking at an integrated solution, what we're aiming to do with this style of integration between GE Vernova and EnergyHub is bring visibility of those DERs managed at the edge, like a customer-owned DER or behind-the-meter assets, into the control room. So we're looking to enable operators to leverage the full suite of DERs available for their grid management strategy and avoid unnecessary actions taken by improving awareness of what both teams are doing. Pivoting a little bit to look at the grid side of things to start, let's quickly cover the importance of a grid-level DERMS like the GE Vernova GridOS solution. So our primary user for our grid DERMS is going to be our control room operators, our grid engineers, and to some extent our program administrators as well. We anticipate these teams using a grid level DERMS solution to do things like bring DER awareness and control into the control room, integrate them with other control room applications like a DMS, and also make sure we're mitigating the DER impact on safety and reliability of the grid as more and more DERs come online. We also want to make sure that they have the opportunity to leverage DERs for their broader grid management strategy by marrying control and visibility of those DERs to network topology awareness and the ability to use targeted DER response to manage network constraint. With this core suite of functionality, we enable the users to incorporate things like automated optimization of DERs for maximum grid efficiency and monitoring and control of DERs from the control room. The GE Vernova GridOS DERMS platform offers a unique grid DERMS solution that can meet utilities where they're at in their DER management journey. We start off with our unified foundational layer that's accessible across all of the GE Grid software solutions. So we have our data fabric layer on the bottom. This is responsible for data processing and storage. We also have a unified UI UX experience that's across all of our DERMS modules. So we're looking to provide our customers with a seamless transition between the various modules offered across the GE DERMS. And of course, we have GE's Zero Trust Security layer. This is to ensure cybersecurity and safety in your deployment and give you the confidence that you're deploying something that's safe for your own networking server. So on top of that layer, we have our 8 DERMS modules. So these can be deployed in a number of different configurations to best suit your DERMS needs, sort of regardless of where you are in your journey. So users can pick and choose the modules relative to their requirements, and we can deploy those as a standalone DERMS solution, or they can also be deployed alongside ADMS, SCADA, and AEMS for a unified grid orchestration. And we've aimed to provide utilities with as much flexibility as possible in terms of the suite of DERs they are able to manage through our DERMS solution. So we do support a number of protocols, OpenADR, IEEE 2030.5, and a number of SCADA protocols as well. And then, of course, through these edge integrations and partnerships, like the one we have with EnergyHub, we're also providing utilities access to protocols like OCPP or proprietary OEM communications that they may not want to natively host within their grid DERMS. As more and more DERs come online, the need for automation and optimization at many levels is a necessity to successfully manage the DER portfolios at scale and to minimize the disruption on the grid. So optimization can take place at several different levels. Our primary focus for a grid DERMS solution is, of course, grid level optimization. That's what the GridOS DERMS solution is best suited to provide. And leveraging awareness of all of the DERs across a network, grid conditions, visibility into real-time and forecasted capacity needs, and of course, network location awareness, we're able to do that grid level optimization and come up with a dispatch schedule or solution that is really targeted towards providing the grid with the constraint mitigation that it needs. By adding in an edge provider integration, we empower users to also incorporate optimization at the VPP and site level as well. So sort of value stacking the layers of optimization that can happen further downstream. Customers that elect to deploy our grid DERMS alongside GE's ADMS also unlock a multitude of benefits. So in looking at incorporating network model data, the GridOS DERMS is designed to fully integrate with the ADMS model management process. So after as-built models are built for ADMS, they can be automatically extracted and added into DERMS. And this is in support of both hierarchical network models as well as full impedance network models. You also have the opportunity to bring in supplemental data. So the DERMS databases and data ingestion methods to store data incorporates a lot of data components that are not traditionally captured in an ADMS. So this might include things like program data, information about contracts, enrollments, operational constraints of those programs. It also may include things like customer-owned DER data that are not traditionally modeled in an ADMS. And by, again, bringing in that layer of integration at the edge, we can extend the level of data that we have accessible all the way up at our ADMS. In looking at topology, we also have the ability to support real-time and look-ahead topology. So ADMS is a system of record for the as-switched state of the network or dynamics. And DERMS is designed to be able to subscribe to those network state changes so that DERMS can be situationally aware of those changes and take that into account when doing things like DER optimization and can accurately reflect the current state of the network. We also have the ability to apply that same functionality in a look-ahead basis. So DERMS is able to include look-ahead optimization capabilities and can be used to enhance to integrate with ADMS switch order or SWO, as well as to receive plan switching information to consider in-day ahead DER scheduling. And last but not least, our real-time integrations. DERMS is designed for secure real-time integration with our ADMS and SCADA solutions. And so this provides access to things like forecasted generation and net load forecasts that can be sent back to ADMS as predictions are made. We are able to expand ADMS's reach by incorporating the IEEE 2030.5 protocol and other non-SCADA DER protocols, allowing controls to be sent directly from ADMS through the DERMS and on to non-SCADA connected DERs. And of course, we also bring a layer of monitoring and visibility, a common theme throughout this presentation, for those SCADA connected DERs into your DERMS so that you're able to incorporate SCADA connected DERs into your broader DER analysis within your DERMS system. So to sort of summarize here, grid level DERMS are an instrumental tool in a utility's DER management strategy. It offers operators a single system which they can view and manage DERs across the entire utility network and use that network and system awareness that they already have in the control room to inform the most efficient use of those DER assets. They're well suited to manage grid-centric DER programs, implement power flow optimization, and to work in lockstep with your ADMS or AEMS solution. And because of that, they provide a sophisticated solution to managing your DERs that is an extension of your existing grid management strategy. And with that, I'll hand it over to Matt now to talk through the value in including an edge DERMS in that solution as well. So Matt, take it away.
Great. Thanks, Kristen. Let's talk a little bit about why a utility needs an edge DERMS. But before we do that, I'd like to get a little bit into some of the macro drivers that are driving the need for DERMS in general and edge DERMS in particular across the industry. The first of those trends is that load growth is back. For many years, load growth has basically been flat in the industry. But as we talk to clients around the country today, one of the things that we're hearing is that over the past couple of years, load growth is back in a big way. And this is driven by a few factors. Electrification is clearly driving a lot of this. And at the same time, we're seeing an increase in manufacturing, growth in data centers around the country, which is really creating a spike in demand. This is very exciting for utilities, clearly, but also many of our clients are concerned about their ability to meet this demand, right? They're having trouble siting new transmission and distribution upgrades rapidly enough to meet the demand. It's not easy to get a power plant online quickly to meet this demand. And these new commercial customers, some of them very large companies in their own right, they're both demanding customers and they're concerned about the ability of the utility to meet their electricity needs. So one macro driver we need to track. At the same time, we're continuing to see massive adoption of behind-the-meter, customer-owned distributed energy resources, which means that there's potentially huge amounts of flexible demand already installed waiting for us to tap into it. So looking across some different types of DERs, by 2030, it's expected that 15% of homes in the United States will have solar installed, obviously delivering significant flexibility, as several million homes already have solar installed today. We're approaching 2 gigawatts of behind-the-meter DER battery capacity, often associated with those solar installations. And EVs in 2024 were 12% of new cars sold. Now, obviously, EVs are a bit more complicated. They're both a challenge and an opportunity for a utility, but on balance, we should be really excited about their flexibility potential as well, both at the bulk and the distribution grid levels. And not pictured on this slide, but in addition, there are tens of millions of connected smart thermostats out there, many of which are already actively providing flexibility to utilities today. So harnessing the capabilities of these behind-the-meter assets into aggregated smart pools of resources that can provide grid services on demand and at scale is really where EnergyHub comes in. So the EnergyHub Edge DERMS is built to bring the flexibility of these behind-the-meter assets and build them into virtual power plants, or VPPs. A VPP is a popular term these days, but what actually is a VPP? Basically, a VPP is an aggregation of a diverse set of distributed energy resources that is aggregated and dispatched in a coordinated way to provide demand-side resources and grid services to utilities. The EnergyHub DERMS connects these customer-owned DERs to the utility and basically allows them to serve as a flexibility asset to the grid operator. Our platform enables the enrollment and management of these devices into aggregations. It forecasts the availability of these assets. It allows for dispatch cross-functionally to deliver grid resources, and then it provides performance analytics after the fact. And as we'll discuss shortly, the EnergyHub Edge DERMS integrates directly with GE's GridDERMS to make all these actions grid aware. So the first step in getting access to a customer-owned asset, obviously, is to build deep partnerships with the B2C companies that are actually building and deploying behind-the-meter DERs today. These companies include leading brands across a variety of sectors, many brands you're familiar with, from leading smart thermostat companies, electric vehicle manufacturers, electric vehicle charging companies, battery storage companies. EnergyHub has the largest device partner ecosystem in the industry, and that really makes our platform even more powerful. We're fully integrated with these partners, so you can think of those integrations both from a technical perspective with the ability to provide dispatch and data capabilities, but also to support customer enrollment, which is a key and kind of underappreciated part of the VPP development lifecycle, and with the other operational processes that are necessary to build and maintain a large VPP on behalf of the utility. So let's dive a little more into how we actually capture the flexibility of these behind-the-meter assets. Basically, as customers purchase these DERs, like their smart thermostats or home battery systems or electric vehicles, they hear about utility flexibility programs, think of Bring Your Own Thermostat program or a managed charging program, through their relationship with the device partners, the B2C brands that we were just talking about on the last slide. These flexibility programs are typically run by the utility and offer the customer a monetary incentive for enrolling their device in the utility program and allowing the utility to dispatch or control their DER to provide flexibility back to the grid. So customers who enroll in these programs agree to terms and conditions. They're doing it with consent, and that allows the utility to leverage the EnergyHub DERMS platform to control their devices to meet a specific grid need. And then the utility teams are able to use data pulled from these devices to analyze how that optimization went in order to inform future grid control strategies. You may ask, is this happening today? It's happening at a fairly massive scale today. EnergyHub's platform alone is controlling over 1.3 million DERs today. That represents almost 2 gigawatts of load. And each of those DERs is actually providing grid services to the utility today. We're doing that with about 70 utilities across North America. And even at those individual utilities, VPPs are happening at scale. Several of our clients are controlling VPPs that represent north of 100 megawatts of flexibility. So you're really seeing VPPs become an active and important part of how the utility maintains grid stability. Now, primarily today, historically, utilities have used DERs primarily to reduce peak demand at the bulk system level, basically contributing to generation capacity deferral and once in a while to transmission and distribution capacity deferral and reducing energy costs. That is the state of the world today. But because the grid is evolving and we need more sophisticated flexibility grid services, and because DERs are becoming more flexible, we're going to see this value stack evolve over time. So in the future, we'll have more flexible DERs, and as the grid's needs evolve, we can fast forward and look at that value stack growing over time. We'll continue to see the generation deferral capacity value as we continue to lower demand during bulk peak system hours or bulk system peak hours. But we're also going to start to look to do more locational-based dispatch, which is very much where our partnership with the folks at GE come in, to reduce non-coincident peaks on specific distribution feeders and at the transmission level, which unlocks greater T&D capacity value. We'll also be dispatching more frequently based on marginal energy costs, which offers the potential for energy arbitrage value. And then the top part of that value stack, you see the ability to deliver ancillary services such as frequency regulation using these behind-the-meter DERs. So overall, you end up with a much deeper value stack, creating more value for the utility and for the customer as well. So how are we actually delivering these multiple value streams in the future? What is the future state that we've reached that allows us to fully realize the financial potential of these DERs? The first is that we're operating all these behind-the-meter DERs as a single virtual power plant via single edge DERMS like EnergyHub's edge DERMS. And that edge DERMS is tightly coordinated with a grid DERMS like GE's GridOS system. The second kind of criteria is that this VPP is responding to grid conditions in near real time. It understands the needs of the grid via our upstream integration with the grid DERMS, and that it's orchestrating and dispatching these behind-the-meter DERs rapidly to deliver maximum value to the grid operator. The third kind of criteria is that we're delivering these resources year-round. And traditionally, behind-the-meter DERs have mostly been seasonal resources because most of the bulk system needs for reduced demand come in the summer, at least here in the United States. But increasingly, we're seeing calls from our clients to deliver year-round flexibility capabilities. DERs are evolving to do that. Customers are prepared to do that. So I think in this future state, we should expect these virtual power plants to be operating as year-round flexibility assets. And if we're doing all these things well, we are unlocking that entire value stack and unlocking a lot more grid value for the utility. That value allows us to potentially pay customers more to make their DERs available to us as behind-the-meter assets, and kind of creates a positive feedback loop or a virtuous circle where we can build virtual power plants at an even greater scale. And I think that scale is helpful for framing up the vision of how we deliver on this overall promise of flexibility. So every utility is a bit different, but it's clear that for the full promise and value of these behind-the-meter DERs to be delivered and virtual power plants to be delivered, you need different teams at the utility coordinating and engaging with the VPP. So historically, if you look at how VPPs have been used today, they're primarily run by demand-side management teams at the utility, typically calling a discrete event with an individual DER class. Think calling a managed charging event on electric vehicles or a bulk system demand response event on smart thermostats. And different device classes are typically seen as separate resources. But as I referred to earlier, the ideal state of the VPP is a synchronized cross-DER aggregation functioning dynamically. And looking forward, I think we will see a lot more collaboration between the demand-side management folks who are typically running these virtual power plants of behind-the-meter assets, and the control room folks who need access to these virtual power plants to extract the true value of the flexibility. And the integration between the grid DERMS and the edge DERMS really plays a key role in delivering that outcome. So in the future, you'll see the DSM teams engaging with the customers, building the resources into virtual power plants, and then turning those resources over to the grid planners and grid operators to enable basically a fundamentally new way of running the grid. And we're very excited about the partnership with GE and its ability to deliver those outcomes to our collective clients. So let's look in a little more detail about how EnergyHub sees the edge DERMS and the grid DERMS working together. So at a high level, the edge DERMS is integrating with the customer-owned DERs downstream behind the meter, owned by the customer, and is also integrating with the utility CIS and MDMS systems on the back end to basically build out and manage the VPP. The EnergyHub system is verifying the customer and device eligibility and enrolling the DER into the VPP. It's then providing the ability to dynamically group those DERs within the VPP, and it's forecasting the availability of those assets to provide different types of grid resources. Then we can take a signal from when we take a signal from the grid DERMS, we can optimize how those devices are dispatched within the VPP in order to meet the requirements of the grid DERMS. And then we can provide data back to the grid DERMS to assess the performance of those devices in that virtual power plant after the fact. And then parallel to the edge DERMS, the grid DERMS basically understands the needs of the distribution grid at any time. It's directly integrated into the utility ADMS and EMS systems, as Kristen was mentioning. So it's handling that distribution level analysis, forecasting the needs of the grid, understanding the need of front of the meter DER assets as well, and providing reporting back to the control room. And then our two systems, the edge DERMS and the grid DERMS, are integrated, and we're communicating resource availability up to the grid DERMS, and then the grid DERMS is sending grid-aware dispatch signals down to the edge DERMS for us to execute on. And basically with these two systems working together in a comprehensive solution, the utility can really leverage the flexibility that can be delivered through these customer-owned DERs enterprise-wide and really maximize the value that we can deliver to our clients. So to summarize, the partnership is really focused on delivering reliable flexibility at every level of the grid. You know, at the first level, we're building grid-aware virtual power plants. So we're efficiently capturing behind the meter DERs. We're analyzing grid conditions to focus on capturing DERs in a specific area to avoid surpassing load limits. And we're overall enrolling and identifying eligible DERs to deliver grid optimization. Once we've got those devices enrolled, we are monitoring what those DERs are doing and providing that information back to the control room. So that allows us to see how DERs can address identified problems in specific grid locations. We can track capacity through the grid operator UI all the way down to the individual DER level, and then forecast that load and capacity availability from enrolled DERs and provide that information back to the control room. And then last but not least, or certainly probably most important, we can provide that control that the utility is looking for of these behind the meter assets. So we've got grid-aware optimization of these enrolled DERs to relieve grid congestion. We can optimize DER behavior for both bulk grid and distribution network needs. We can utilize these DERs to address congestion issues and aid in distribution upgrade deferral, and then automatically leverage the DERs down to the feeder level to improve power quality and reliability as well. So it's really kind of providing a comprehensive solution that maximizes the value of the asset to the utility. So with that, I will turn it back to Kristen to continue the discussion.
Yeah, thanks, Matt. So now that we've talked a little bit about our respective solutions, let's dive into what an integration between these two systems actually looks like for the user. So on this slide, we've mapped out what the user experience looks like in terms of which system or interface would be the primary system for common actions that a utility user might take throughout the DER lifecycle. So we've split our common actions up across likely user personas. So you can see our program administrator here up top. This role may need to complete actions in both systems, but it's pretty much limited to actions that are either not quick response or are not particularly repetitive, like configuring a new program or reviewing post-event reporting, reviewing customer enrollment, that type of thing. And you can see this is where we have the most interaction between both systems, where the user might need to go into one or both to accomplish the full life cycle of their tasks. But you can see on our grid operator and grid engineering roles, the need to jump between systems is essentially eliminated here. And that's one of the primary goals for this style of grid to edge integration. We want to provide a single pane of glass view for the control room as they manage DERs on the network to eliminate risk or error that's prone to jumping between systems, minimize their need to manage multiple credentials, and also to allow them to view things holistically all in a single system rather than having to take into consideration DERs in one system and how they might interact with DERs in another. So we can see here that we're really aiming to give that single pane of glass view for the control room so that they can take action completely within a single primary interface of that grid DERMS and still see the benefit from everything they have enrolled at the edge. So in looking at our sort of core functionality, we've got 4 main pieces that we'll talk about today. We'll actually do a demo of the dispatch functionality, but to kick us off, I wanted to talk a little bit about program configuration. So here we see that, again, our program administrator is going to set up a new program in both systems to set the foundation for controlling those customer-owned assets through the grid DERMS system. So on the grid side, we have program configuration that's going to capture the things that are important for a grid operator to know. Things like program parameters or constraints, operating hours, when they are able to leverage these assets. That's all going to go on the grid side. In the Edge DERMS system, we have that plus our customer enrollments and registration, which as Matt mentioned is a really critical part of the VPP lifecycle. And then we also have the grouping of those assets into the groups we would leverage to dispatch from the grid side. So we see sort of a parallel system here where we have the program configured in both sides, and we're capturing in each system the information that's most relevant so that we're not creating too much clutter and noise. And looking at dispatch functionality, and this is what we'll actually demonstrate in a few minutes here, we can see that the source or origin is actually coming from the grid side, and that data is flowing through to the Edge DERMS system. And so here an operator can create a dispatch in the grid DERMS system, whether it's manually through the UI, by leveraging APIs, or automatically through something like an optimized solution or an external scheduler application. Those dispatches are created on the grid DERMS and then flow through the Edge DERMS, leveraging an OpenADR integration. And that event is then created, and downstream from the Edge DERMS system, individual controls are sent to the DERs enrolled in that program. Visibility is very, very important. It's been, again, a common theme throughout a lot of this presentation. It's really critical that we're getting telemetry and measurements from those behind the meter customer-owned assets at the edge all the way up to our grid DERMS system so that we're bringing that awareness into the control room. So for visibility, we see that data flow from the edge into the grid DERMS system, leveraging that same OpenADR integration. And this component is really integral in providing the control room with visibility of these DERs so that they can make sure that they're taking accurate action and incorporating them into their grid strategy accurately, bringing them into their optimized solutions. All of that relies on this data exchange of telemetry. And so really critical to have that coming from the edge into the control room. And then finally, in sort of our dispatch lifecycle here, we do have event reporting. Again, looking at sort of a parallel system here, predominantly for our program administrator, but also some application for our control room operators as well. So on the grid side, we have post-event reporting that's program level, and it's really designed to give the operator some indication of control activity and provide information on how frequently or how often the program itself has been dispatched. On the EnergyHub side, we can see we have what we call detailed event reporting. And this is really targeted towards our DSM or program administrator teams that are going to review things like customer participation, performance, and get an in-depth analysis of what occurred in that event, device by device. So you're really going to get a more detailed view on the EnergyHub side, because that's the information that's most pertinent to that user group. So again, looking to sort of split functionality based on the information that's relevant for each user persona. And now I think we're going to go ahead and jump into a quick demo for our integrated dispatch functionality. Today in our demo, we'll walk through the dispatch creation process from the perspective of a control room operator. The operator, having identified an area of constraint on the grid, will seek to leverage all available DER resources in that location to minimize the impact. This includes customer-owned behind-the-meter assets that are managed at the edge. Primary protocol used for this integration is OpenADR, which covers the point of interface for issuing controls and exchange. So we'll also talk a little bit about how that VEN or virtual end node is modeled within the grid level DERMS and how that integration works. To start, let's take a look at how those assets are modeled on the grid side. So what we have on screen here is the DER gateway module within the GE DERMS. And this is the module that's our primary point of interface for our integrations. It's also our primary point of interface with clients in the field. And so this is where we do our dispatching. This is where we collect measurements and telemetry from the field. And it all streams back through this module into the broader grid DERMS system so that the control room operators can access it. So in this module, we have to manage our DER and device data and lifecycle. And the screen we're looking at here is our registration and provisioning screen where we do just that. So here is where an operator or a system admin would actually model all of the system data that they're going to then leverage for controls and collecting telemetry of those DERs. What we're looking at here is our control groups. These control groups essentially represent an end device within the DER gateway. And this is our communication proxy. This is what we would actually typically send a signal to. And so you can see here, we've got some control groups modeled at the feeder level. And you can see it's just a single asset representing each feeder level. So I want to talk a little bit about our grouping strategy and modeling strategy for our edge integrations. It doesn't really make sense for a lot of the customer-owned behind-the-meter assets to be modeled individually within the grid level DERMS. And the reason for that is the control room often isn't looking for modeling assets that are relatively small in size because it creates a lot of clutter and a lot of noise. So the strategy that we have developed alongside EnergyHub is actually to model our DERs from the edge as DERAs or DER aggregations. And those are a unique single asset at a relevant grid network topology level, whether it's feeder, substation, feeder segment group. And we're going to create a single asset on the grid side that actually represents many, many assets down at the edge. So we see our control groups here. These actually represent groups of assets in the edge side, and we'll take a look at that in just a minute. But you can see on the grid side, it's just a single asset. This is to reduce some of the clutter and some of the noise that might come from modeling everything independently. It's particularly important where we're looking at integrations with the ADMS side as well, because we don't want to create a lot of clutter on those network topology maps either. Before we jump over to dispatching, I also wanted to touch just briefly on the aggregator object in the DER gateway. Gateway is first and foremost was modeled after a IEEE 2030.5 server. So our aggregator object really represents a communication proxy. So in looking at integrations with edge providers like EnergyHub, we would set up that edge integration as an aggregator object in our system. That's going to just serve as the communication proxy, or in this integration's particular scenario, a VEN, virtual end node. And that's where we're going to model that and set that up so that we have that communication proxy available for dispatch. And you can see this is also where we collect things like certificate data. So when we're setting up and registering that VEN, this is where that would take place. Okay. Now we're going to jump over to the EnergyHub side, and we're just going to take a look at how some of the assets are modeled there.
Great, thanks, Kristen. So now we're in the EnergyHub Edge DERMS. This is a view that the demand side management program manager would have in setting up the Edge DERMS and the aggregations of DERs that we're managing for integration with GE's system. So we're going to take a look at the DERs that are enrolled and grouped within the DERMS. So at the time of enrollment of the DER, the first EnergyHub's grid or Edge DERMS verifies eligibility and connectivity of the DER. Then we group those devices automatically. That's generally based on a set of standard attributes that we offer within the system that does include network topology location. So here you can see each of these groups contain a subset of the total DERs enrolled, and note that those group names correlate to the network feeder we saw in the GridOS UI. And these groups are what the grid DERMS can call on to dispatch when the particular area of the grid requires flexibility and we receive a signal from GE's grid DERMS. So I'll hand it back to you, Kristen.
Thanks, Matt. Let's go ahead and take a look now at what a simulated dispatch might look like between these two systems. So in our scenario, we mentioned that the control room operator may have noticed a regional constraint on the network that they would look to address. So let's say that they noticed that constraint on our Muirfield substation, or even more targeted, we could say we want to address a constraint on just a specific feeder. So we'll go ahead and select our control group for that feeder location. And from here, we can go ahead and create a dispatch to address the constraint. For our control type, which is the operational mode in which we would send the signal to the DER, we'll go ahead and select contracted flex. What this means is this is going to be basically the contracted flexible capacity that this asset has available. So for the edge, these DERAs, DER aggregations, are going to have a summed total contracted flex value that we get from EnergyHub. And the reason we're going to use this dispatch type is because, as we mentioned, we don't have each individual DER modeled here. So the grid system is not accounting for things like customer opt-outs, connectivity on a finer level. We're looking at the summed total capacity for this grouped asset. So we are going to let the edge DERMS for EnergyHub manage the fine-tuning of this dispatch, any additional optimization, and factor in any additional customer opt-outs and things like that, so that we can keep to a streamlined model version here on the grid side. So we'll choose contracted flex, and we'll go ahead and set that as our control. And you'll notice, again, we don't have to enter a control value. This is going to automatically pull in that flexible contracted value. And from there, we can go ahead and hit our dispatch button, and we will set our dispatch schedule. And we'll go ahead and set this for 1 o'clock. And let's say it's a 2-hour dispatch. So we'll set it to end at 3. Okay. And now we'll go ahead and just push this dispatch through. This is going to send that control to the EnergyHub VEN to trickle down into their system and create a dispatch there. So now we'll jump over to the EnergyHub side and see that control created.
Great. So within the, back on the EnergyHub side, so we can see that the dispatch signal from GE's grid DERMS has been received and an event has been created within our edge DERMS. So once we receive that dispatch signal, the EnergyHub Edge DERMS will dispatch the relevant group based on the predefined dispatch strategy that we've already agreed with the grid DERMS. So in this case, we're dispatching the group corresponding to feeder 0531, as Kristen referenced when she was setting up the event in GE's DERMS. So the targeted devices within that group are automatically controlled via our DERMS through our direct-to-device integrations we have with our device partners. And we, in those integrations and the dispatch, we take into account the individual constraints and capabilities of each device we are dispatching. So during the event, the utility users of the edge DERMS, so the demand side management program managers, can track the success of the control strategy in real time using the dispatch funnel visualizations and near real-time event dashboard in EnergyHub's utility user interface. So the result is that we're basically making it possible for the control room to access the scale and breadth of these behind-the-meter VPP resources, and we're enabling communication with a broad system of DER partners without the GE Grid DERMS having to support different interconnection protocols. Now that we've seen a demonstration of how the GE and EnergyHub DERMS interact, let's talk a little about how this solution will evolve over time. So as you saw in the demonstration we just showed you, currently we're looking at providing location-based grouping and dispatch of DERs behind the meter. But over time, we see that evolving to more dynamic DER dispatch, where we'll be using the automated constraint management that exists within GE's Grid DERMS to automate the creation and the dispatching of different groups of DERs within EnergyHub's edge DERMS in response to grid constraints. And eventually we see an evolution to truly automated AI-driven dispatch, where we leverage AI to generate grid optimized schedules and use the data we have within the EnergyHub platform to inform these optimization strategies.
Great. Thank you, Matt. It's really great to see that full walkthrough of the integration of our solutions. There's clearly a lot of innovation and value here, and sounds like it'll just keep getting better with time. So now we're going to open it up for some questions from the audience for Q&A. I see a few great questions have already come in, so let's dive right in. Kristen, maybe to kick things off, we received a question. Does EnergyHub or GE Vernova see that Grid DERMS would have visibility to every behind-the-meter DER within edge DERMS, or only at an aggregate level?
Yeah, so this is a great question, and it kind of goes back to that modeling strategy that we talked a little bit about in our demo. So this can sort of go two ways, but I'll start by saying that the most important piece of context here is the scale of the asset itself that we're talking about. So keeping in mind that at the Grid DERMS level, the primary user is going to be control room operator, we recognize that they don't necessarily want to see the granularity of every very small scale asset that might be modeled at the edge, things like thermostats, hot water heaters, pool pumps, that type of thing. That's where we really take that aggregation strategy into account. So by grouping that type of DER at a network topology relevant group level, whether it's a segmentation of substation, feeder segment, that's going to allow the control room operator to see the sort of summed capability and capacity of those smaller DER assets, issue controls to them in a group setting, and leverage them for things like localized constraint mitigation. So we're grouping them in sort of a smart manner to allow for them to still be leveraged for specific regional constraint issues without having to dispatch, let's say, an entire thermostat program. But we're still trying to keep in mind the scale that's relevant and important for a grid operator to see at the Grid DERMS level. We don't want to create too much noise or clutter in the data model that we're presenting to them. That actually, there was another question about sort of the granularity of dispatch. Are we able to dispatch individual DERs at the edge from the Grid DERMS, or is it an entire program dispatch? We are allowing, based on that grouping, for some more targeted dispatching to be done. If it's a larger asset, curtailable load, or a large rooftop solar array that's being managed at the edge, we might elect to model that independently in the Grid DERMS as well. So the context that's important there really is the scale of the asset.
Perfect. Great answer. Thanks, Kristen. So now building onto this, we have another question here. How do you ensure device telemetry is as real time as possible? We see that not all OEMs are willing or able to provide that information. Matt, could you take this one?
Sure. Yeah, great question. So the person who asked the question is right. The OEMs we work with across our DER partner ecosystem do provide telemetry at different granularity and also in different levels of quote unquote real time. today our system is able to account for that, and for the grid services that we're typically providing at this stage, mostly focused on capacity. That real time, or that the latency with which that control and data comes is fine. I think as grid service models start to evolve and there's more potential compensation available for DER ecosystem partners, basically that there's financial incentive for them to get closer to real-time data and dispatch, they'll make the improvements to their platforms to provide that. At the moment, we're not quite there in terms of the financial incentive for a thermostat manufacturer or a battery provider to provide truly real-time telemetry. But I think over time, we'll see the financial incentives evolve and push the technology in that direction.
Awesome. Thanks, Matt. Another question, interesting question here for you, Kristen, I think twofold. So are GE Vernova's DERMS and ADMS two separate products or one bundled product with different modules? And how does GridOS DERMS with other ADMS providers?
Yeah, it's another great question. So maybe starting with the product differentiation on the GE side, our GridOS DERMS solution is a separate product from GE's ADMS solution, but the two are designed to work interoperably, meaning that if they're deployed side by side, they do have internavigability and interoperable functionality that comes natively out of the box. In terms of integrating with third-party OMS or DMS systems, we do have some flexibility in being able to ensure compatibility with things like integrated model management, but it wouldn't necessarily have that integrated interoperability that comes from the ADMS and GE DERMS side-by-side deployment.
Thanks, Kristen. Here's another question for you, Matt. Have you built this relationship out functionally at any utility to date?
Yeah, great question. So EnergyHub and GE do have a shared client that wants us to deploy this, and we're currently in discussions with them to scope that out and do anticipate deploying with them in 2025. So we'll be in the field soon.
Good to hear. And then Kristen, I'll give this one to you. How do you all handle customers who want to integrate other third-party data streams into the DERMS platform?
Yeah, so on the GridOS DERMS side, we do have a couple different interface points that can be used to build out sort of a broader integrated partner network. So we have partnerships and integrations with EPEX spot and nodes for things like more advanced market orchestration that you want to tie directly into your grid DERMS system. We also have external APIs that are accessible for things like weather forecast data ingestion or things like that, as well as a handful of externally available APIs for dispatch scheduling, registration of new data into the system. There's a couple different points of interface there as well. So we do have a broader partner ecosystem for the GridOS DERMS solution that includes EnergyHub, but also includes things like the markets orchestration partners that we have, as well as our externally available APIs for third-party data ingestion for things like forecasting or dispatch scheduling.
Great, thank you. I think on a related note, some questions around what version of OpenADR is supported. Can you follow on with that one?
Yeah, so today we support OpenADR 2.0A and B. I know that 3.0 is just published, so it's obviously on the roadmap to be able to support that as well. But it'll be some time before I think that's widely used across the industry. So focus right now is on 2.0B.
Thank you. I think another question here, let me pull. So in your conversations with utilities, do you find that there is general industry alignment, understanding of the terms grid DERMS versus edge DERMS, or is there confusion, conflation with things like ADMS, DMS, or DRMS? Maybe I'll open it up for both of you if both of you want to respond there, and whoever can take it first, go ahead.
Sure. I think we'll have different perspectives, but probably aligned at the same time. So I think over the past year or two, we've started to see the concept of grid DERMS and edge DERMS be more universally accepted, at least on the demand side management and customer facing clients who EnergyHub spends most of its time with. Hopefully we explain some of the differences in how those two platforms work today, where the edge DERMS is looking more downstream at behind the meter devices, and the grid DERMS is providing that grid level orchestration. So I think it's not perfect, and there is still definitely, there are some companies call themselves like grid edge DERMS, for example, right? So, but I think there is increasing alignment that a utility needs two types of DERMS platforms in order to fully get the value out of DERs, and the term for those will be grid DERMS and edge DERMS.
Thank you.
Yeah, I would agree and echo Matt there. I think we are starting to see an emergence of an understanding of the delineation. Places like Guidehouse have sort of separated their ranking system even between the two levels of DERMS solutions available in the market. I think DERMS reminds me quite a bit of VPP a couple of years ago, right? I think everybody's got their own maybe subjective definition of what's entailed, but as Matt said, we're focused on the orchestration of DERs, depending on if you're more focused on the broader grid level orchestration of them, or if you're focused on the maybe optimized local or customer side of it. I think that's really where the delineation comes into play for us.
Thank you. Kristen, another question here for you. Can we get the real-time monitoring of edge DERMS passed back to grid DERMS more in real time, or is it just the aggregated telemetry data?
Yeah, and Matt touched a little bit on this one in his answer with telemetry. Some of this is limited by the OEMs down at the edge and how regularly they are reporting data back. But we do, part of the integration between these two systems is to ingest that telemetry data from the edge through that same OpenADR integration back into the grid DERMS system, so that our control room operators have that visibility, and so that it's also looping back into any layered in optimization models or things like that, and can be factored into those pieces of the broader grid orchestration strategy as well. So as readily as telemetry is available from the edge, we will be ingesting it into the grid side solution.
Okay, thank you. Another question that has come through: what are the ways that utilities manage these communication workflows today? Can either of you speak to that?
Yeah, I can maybe take that one. It's a great question. From my perspective, we touched a little bit on this in the beginning of the very beginning of the presentation. To date, a lot of these communication workflows tend to be maybe siloed between a couple different teams within the utility, where one group might be managing DER orchestration at the edge, another group would be managing maybe the larger scale or direct utility owned DER orchestration from a larger grid level within the control room. We don't really see a lot of crossover as those two systems stand alone without this style of integration. So the goal of really the primary goal of this integration is to bring that communication workflow into a single line, so that both parties are aware of how those DERs are being used and have visibility to loop in how those are being used into their own strategies. So to date, we see a pretty siloed communication workflow between the two different systems. As we introduce more integration, I think we'll see that becoming a steady stream workflow.
Perfect. I'll give us one more question here before we're at the top of the hour. Is having forecast data for load demand and capacity important if the customer has visibility to real-time data?
I think I can answer that, and maybe then Kristen, you can follow on. So I think from the EnergyHub edge DERMS forecasts what we anticipate aggregations of how we anticipate aggregations of DERs will perform in the future, either what primarily what potential resource they can provide to the grid DERMS at whatever grouping the grid DERMS provide. So from that perspective, we see the forecasting of demand and capacity to be an important component of value proposition we provide to the utility and to the grid DERMS, and then also only becomes more valuable as we have visibility into the real-time status of those devices, because they are as behind the meter assets we provide as customer owned, are going to perform differently based on variables outside just their real-time status at any given moment. So I think those forecasts remain important.
Yeah, thanks, Matt. I would agree. I'd say it sort of falls into two buckets of response. So obviously you have your real-time response responding to realized constraint issues. That's going to be leveraging your real-time data to inform those decisions, right? But then you have your maybe proactive response for automated risk mitigation or constraint mitigation that's based off of forecasted grid conditions. So those forecasts can be really important those forecasts from the edge can be really important in feeding into your broader grid load forecasts so that they can be factored into those maybe optimized forecast runs. So you can take proactive response, leveraging your DER portfolio as opposed to waiting for that constraint to be actualized. So I would agree. I think there's a lot of value in bringing those forecasts into your broader grid management strategy.
Okay, great. Thank you both for great insights and diving deep into those questions. We tried to get as much in as possible. I know there's a lot more, but since we're at the top of the hour, that brings us to the end of the Q&A session. I really want to thank our engaged audience for their thoughtful questions and contributions to the discussion. For those of you whose questions we didn't get to, don't worry, we'll be following up over email and also provide everyone with a recording of today's webinar. So thank you all again for joining us today. We look forward to continuing these conversations in future webinars. But until next time, thank you, and we hope you have a great rest of your day.
Thank you.
Thanks so much.